In this video, we're going to talk about the properties of rectangles and how we can use that to solve for the value of x, to solve for missing sides, to solve for missing angles, to solve for missing diagonals, right? Just to solve for these missing pieces in these shapes. So rectangles are going to hold all of the same properties as parallelograms and then have special properties of its own. So let's refresh our memories on what those properties are for the parallelogram, and then we'll go into those that are specific to the rectangle itself. So the rectangle is going to have all 5 of the parallelograms. The first one of the parallelogram is that opposite sides are going to be parallel. Okay, opposite sides are parallel. Opposite sides are also going to be congruent. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals will bisect. Again, these are all properties we talked about last class that are true to the parallelogram. And a quadrilateral is a parallelogram. So if I come over here to my side, I can actually mark all of those things in this shape. So we know that opposite sides are parallel, right? So those are the arrows. We also know that opposite sides are congruent. So AB is congruent to DC, and AD is congruent to BC. We know that opposite angles are congruent. So angle A is congruent to angle C, and angle D is congruent to angle B. We know that consecutive angles are supplementary, which just means they add to 180. So please, if you need that there, please make sure you add that. Okay, and the diagonals will bisect, which means that AR will be congruent to RC, and RD will be congruent to BR. Now, some of these may change when we talk about these special properties that belong only to the rectangle. Now, there are 2 for the rectangle that are specific to just the rectangle. They're going to have 4 right angles. 4 right angles. Let me make that darker. I feel like that's really hard to see. We'll go with blue again. Okay, 4 right angles and diagonals that are congruent. Okay, and diagonals that are congruent. So that means on our picture, I can actually change all of those to have 1 marking because they're all going to be the same. Not only do they bisect, they're equal to each other. All of them are, okay? Including like DB is congruent to CA. Okay, and I can change my angles there to all be right angles. So they all get the box in the corner, which means they're all congruent and they're all supplementary, right? Because 90 plus 90 is 180. So these are all right angles in the corner. Now, one thing to keep in mind is what these might be telling us, okay, and how we might be using those. So if we've got 4 right angles, we might have to use things that involve the right triangle, right? So think about things that involve the right triangle, like a triangle has 180 degrees, or Pythagorean theorem. Like those are things we might have to use here when we're talking about that. And when we're talking about diagonals being congruent, that just means we're probably going to have to set those diagonals equal to one another. So those are things to keep in mind when we're going through trying to solve these problems. So let's look at this first one. We're going to look for all the missing values in this piece. We're going to use lots of different properties in order to find these. So I'm going to start with finding y. Remember, we know our sides are congruent. We know opposite sides are congruent. So I'm going to use a color to signify that those opposite sides are congruent. So I'm using that opposite sides are congruent. So I'm going to write that out because I don't want to forget my properties, right? Opposite sides are congruent. Okay, so I'm actually going to use this property for 2. I'm going to use it to find y. So we're going to have 2y plus 3 equals 5y minus 6. And I'm actually going to use it to find k. But let's find y first. Okay, so I'm going to subtract 2y from both sides. And then I'm going to add 6 to both sides. And divide by 3. Now, if algebra is not our thing, remember, you can definitely type that into Desmos. So y is equal to 3. That's one of our variables we've found. Move that to the side here a bit. Okay, and then the other one we could find from that is k, doing the same process, right? AC is going to be equal to BD because those are opposite sides. So I'm going to have 8k minus 13 equals 7k plus 11. All right, so I'm going to subtract 7 from both sides. We get k minus 13 equals 11, and then we'll add 13 to both sides. Again, algebra not your thing, please just type into Desmos. And remember, when you do, make sure you use your variable as x instead of k or y. And we will find that k is 24 there. All right, so we found k and we found y. The only one left here is x. And the property that we're using is going to be slightly different, right? This is at our angle position. And we're using that property that's only specific to a rectangle, sorry. And that is that all 4 angles are right. Right, we're using that all the angles are right angles. And remember, right angles means they're 90 degrees. So we're going to say x plus 40 equals 90. And then we'll solve for x. You can type that straight into Desmos, or you can do some algebra here by subtracting 40 from both sides. And we'll find that x is equal to 50. For our next example here, we've got rectangle ABCD, and we want to solve for the value of y and z. Okay, so this one we've got to use some properties of our rectangles. Remember, I know that we're talking about angles, so I know that these angles here are right. Now, if I traced what I have here with z, notice that I have a right triangle, and I've got 2 angles of the right triangle, and I need the third. So there's 180 degrees in a triangle. So we're actually going to say z plus 35 plus 90. Please, if you need to write 90 over the box, do so, equals 180. We can type that straight into Desmos and solve for z. I'm going to solve by hand here. So we would have combined our like terms. And then we would subtract 125 from both sides. And we'd find that z is 55. Okay, so now that I know this is 55, and we know that this, again, is 90, we can use the same property we used last time, which is that all angles are right. That's what we're using here. I'll write that out for us. Right? So we're using that property again, and we're going to say 7y plus 55 equals 90, and then we're going to solve for y. So subtract 55 from both sides. Again, you can definitely type this into Desmos, just use x. We're going to get 35 there, and we'll divide by 7. So y is equal to 5. And now we have solved for both pieces. We found z and we found y. Again, that was just using that all the angles are right there, and some of our previous knowledge. For example 3 here, it says BD is 10. Okay, so BD is the full diagonal length here. So we know that whole thing there is 10. And we want to find the value of AJ. So here's AJ. AJ is not the full piece. It is part of the piece. Okay, so what do we know about the diagonals here? There's two properties that we know, and we might end up using. Diagonals bisect, and because it is a rectangle, they are congruent. So we're actually going to use both of those things here. So I'm going to first use the fact that they're congruent. So if they're congruent, I know that AC is also a full length of 10. Okay, so now I've used the fact that they are congruent, and then I only want AJ. Remember, they bisect, and bisect means to cut in half. So we're going to take 10, and we're going to divide it by 2. And this will equal AJ. And so 10 divided by 2 is 5. Again, we use two properties there to get our answer. Last example here. We've got quadrilateral RSTU is a rectangle. Given that RT, okay, so RT is this diagonal here, is 5x plus 8, and SU, so STU, is 28. We want to solve for x. So we're going to use a property of our diagonals again, and this time we're just going to use that diagonals are congruent. We don't need the fact that they bisect here because we've given the whole pieces. So we're just using that they're congruent, and we're going to just place them equal to each other. So 5x plus 8 equals 28. And then we are going to solve for x. So let's subtract 8 from both sides. 5x is equal to 20, and then divide by 5. Again, algebra not your thing, that is okay. Please just type this into Desmos with x as your variable, and you will get 4 for the value of x. We're going to do a lot of practice of this in class. If you have more questions, please make sure you ask. Bye.